Hello, everyone. Welcome back to Geography 1140. We're doing Global Casino this semester, and we're doing Chapter 1 today. It is the 16th of January. It is Thursday of week 1. So, just a couple announcements before we get into it. Has everyone had a chance to take a look at the Canvas shell so far? Sign the participation agreement, look at the syllabus, do all that good stuff that we talked about on Tuesday. Good. Then you are on your way. I still don't have a GA. Hopefully I'll get one soon and I'll introduce them to you. But when I do, you'll be the first to know. I also will be posting my office hours by the end of the day tomorrow. So look for those as well. We're going to do we have like 2 days a week, Tuesday and Thursday. And so usually it's going to be 2 chapters in a week, one on Tuesday, one on Thursday, just because of 22 chapters in the book. And there's 16 weeks, but there's really not because tests and stuff like that. So it comes out to just a little bit more than 22 meetings that we're going to have. So usually we do 2 a week, but because we did the syllabus on the first one, we're just going to do 1 this week. We're going to do chapter 1 on the physical environment. So physical geography is what it's known as. And this will let you kind of dip your toes into the book. But we want to take it slow to get started because people are still adding to the class. Some people still haven't received their textbook. Some people are still figuring out what's going on. So we're just gonna do 1 this week, okay? Does that sound good? We do have some things coming up though. So if you take a look at the syllabus, even though it is week 1, we still got to do stuff. Here we go. I think it works now. Let's see. Yeah, it works now. That's fun. So we're down here in week 1. You got your participation agreement, which most of you have already done, and that's easy to grade. You have discussion board number 1, which is the introduction. Remember, you're going to post a headshot of yourself, as well as those kind of important facts about who you are and why you're here. And then quiz number 1, remember, it's going to be 10 questions from chapter 1. If you haven't read the text, I have a PowerPoint we're going to go over in just a little bit, which talks about like most of the things in chapter 1. It's not every single thing, especially some of these pictures and graphs. I encourage you, if you're a visual learner, to look at because they do get referenced on the quiz, and just kind of get a general feel for what chapter 1 is. We'll try to take as much time today as, but you know, it's not a very long chapter, so it might not take the whole time. Okay, so quiz and discussion board number 1. Yeah.
I've ordered my textbook, but it's on back order.
I believe it.
So
you're not the only one.
They say so mine.
Yeah.
Cool. I've also ordered one for the library, but it's on back order. So
Cool.
yeah. How about the rest of you? Anybody got a textbook?
I was able to get an old version of it.
Yeah.
I'm waiting on my newest edition.
Does anybody have a text? There's one. The most popular guy in school, right? Let's buddy up. But most of what is on, you know, I just kind of made these based on the chapter, so you should get a lot of it. But I encourage you to make friends with each other and then hopefully find the textbook. Was it not at all in the bookstore? They not.
I mean, I ordered it from the bookstore and I got a notification on back order, and I ordered it like pretty far when you posted the syllabus.
I didn't even like order it. I just went in there with my schedule and they gave it to me.
Oh, so they had at least a few copies. That's interesting. I don't know
where all the other copies might have been at, but
yeah. If there were no copies, that'd be one thing, and I'd be like, it's probably me. But if there were some copies, then I feel like it's that.
I don't know. I guess I was just lucky or something.
Yeah, they were 1.
The 1 textbook.
Yeah. Well, we do have. I have 1. He has 1. So hopefully we'll get some more in here soon. But if you're interested, you know, you can always come by my office hours or make friends with someone who has a copy and take a look at the book. But I encourage you to.
Page of chapter 1.
It's not super long.
24?
Yeah. but a lot of them are pictures. I think like half of it is
Yeah, there's
pictures.
like-
so-
I'm mostly just worried about the figures part of the quiz, like I'm sure I'll get most of the information from the PowerPoint. I'd like, would it be effective if I like took pictures of the figures?
I think that would be a good way of doing it.
Okay.
Cause I think it's this 1.12, I think is on there. And maybe some of the other ones, but I think that's the one in particular. I can look and get back to you. When is your book supposed to arrive?
I don't have a date, the notification from the bookstore is literally just, that sucks, bro, see you when it comes in.
Yeah, I ordered mine about maybe a month ago.
I'd say,
I,
yeah,
I went into the bookstore
And they didn't have it? Let me look something real quick.
So all they gave me was like a note, we're gonna call you when it comes in.
yeah.
Maybe. Well, I'm not sure. But like I said, we do have a copy coming from the library. It should be here sometime. But I may try to find an e-copy and post it or have the library post it. We'll see what we can do. But you're not the only class who's had issues with that, I guess. Okay, and if you know when your book is coming, you can just kind of wait and take the quiz when it comes, right? Because it's still the beginning of the semester, and I am pretty lenient in the beginning because everybody's getting settled. Any other questions before we get more into things? Okay.
I mean, it's due tomorrow, right?
But if you want to just wait till next week and take it, hopefully your book's here by then.
Okay.
If not, we can reassess. That sound fine? Okay. I don't have a GA, so stuff's not getting graded anyway.
Okay.
Yeah. Okay. Hopefully by next week, you'll have books. I'll have a grader. This will be a real school. Okay, there we go. Anyway, welcome back. All right, so we're going to do chapter 1 today. And we'll also kind of just get do a little introduction time with each other. No, we already did that. I have too many classes. And we'll start on chapter 1, and we will kind of talk about how chapters 1, 2, and 3 kind of fit into the bigger picture. So if you've looked at your textbook, if you have it, or if you've looked at the Canvas module, you can kind of see the PowerPoints, you can see the titles. And chapters 1, 2, and 3 are a little bit different from what we're going to do in the rest of the textbook. The textbook, Global Casino, is set up to talk about, it's an introduction to environmental issues. That's what I like to cover, right? And most chapters are going to be a different environmental issue facing planet Earth, right? There's a chapter on climate change, there's a chapter on acid rain, there's a chapter on coral reefs having problems, there's a chapter on dams and rivers, there's a chapter on urban problems and waste and trash and mining and energy, right? So each week is another topic, right? Except for the first 3 weeks are a little bit different, or the first 3 chapters, right? The first one is physical environment, second one is human environment, and the third one is sustainable development. These are going to really scaffold the rest of what we're going to do in here. This is, think of it as like a part 1 of this class, right? And it's going to give us the constraints or the like basic outlines of what we need to know in order to talk about big issues. And I don't know if you've noticed in the political and social discourse lately is people like to weigh in on issues that they're not necessarily experts on. So my idea is that maybe we become a little bit of experts first on the topic of geography and how planet Earth works. And then we can start talking about these big issues which are affecting us and thinking about how we might best solve them. Okay, so today in chapter 1, we talk about physical geography or the physical environment. So if you're thinking about geography, I would ask how many of you are geography majors, but the answer is none of you because they got rid of geography as a major here. So none of you are. What is geography? That's a good starting point. And why are we all in a geography class? None of us are geographers.
The study of the earth.
Yeah, the study of the earth. And if you're like me, back when I was a kid, I took geography and it was all maps. It was like, which state is the one by North Dakota, South Dakota? I'm like, great. It was like map spelling bee kind of thing. But geography is a whole lot more than that. And it's actually become, which it's kind of short-sighted of the university to like have folded the geography department mere years before geography becomes one of the like hottest majors for people to have around thanks to things like GIS, right? But geography is more than just maps and thinking about Mercator projection versus, I don't know, globes and all the different projections. But like, what is planet Earth, right? Like, what is the inorganic as well as the organic components that go into making this planet run, right? So what are the different kinds of things we might talk about? And we're talking about planet Earth from like, big picture scale. We're flying in on a spaceship. We see planet Earth. What's going on there? Throw a picture up there. Planet Earth. Here we are. What kind of stuff is going on here? It's a nice picture. Yeah, there's clouds. There's the atmosphere, right? Our spaceship, we're flying into the solar system. We see that one of these planets is really different from the other ones. It has an atmosphere that is made up of oxygen, right? And it's got all these very active components. How do we know that's an active atmosphere? What's going on there? Yeah, it's moving and it's not all the same. You got these swirls, you got hurricanes, you got lines of clouds, you got all kinds of stuff, right? So we know it's active. So we got the atmospheric component, the gases that we breathe and how they move around. What was somebody else said something else? A lot of water, right? Called a hydrosphere. A lot of water moving around that planet too. And just like the atmosphere, it's not static. It's not just a completely blue sphere, right? There's land and there's water, and we can see the water is moving, and you can even see different shades of blue, right? Maybe that means it's shallower or deeper, or the water is moving in certain ways. What else do we see? Planet Earth. Yeah.
We see various land masses.
Definitely.
From continents to smaller islands and.
Yeah, right. We got this distribution of land and water. And within that, on the land, what do you see on the land? Can you make out any details or features? Can I zoom? Enhance. All right, let's see. Yeah, mountains, rivers, right? So we got these geographic features. We can see topography. Some places are high, some places are low. We can also see different colors on the map. What do you think that means? Vegetation, right? So far we've talked about things that are not alive, right? The atmosphere, the water, the rocks and stuff like that. But there is also a living component as well. We can't really see it as well, maybe animals, but we can definitely see plants, but we can probably see people as well. How might we see people on this map even?
Lights.
Yeah, maybe at lights if we have it at night, or we could even see urban areas of buildup, or we can see places maybe in the Amazon where there used to be trees, but now are no longer there, right? So people can affect the environment, and we can see that either directly or indirectly. And what we're going to talk about today is that first group of things you said, all the inorganic stuff, all the stuff that's going on planet Earth, not related to people, especially. We can also talk about animals and plants and things like that. And then the second time next week, we're going to talk about the human environment and how people change the Earth, change those kind of natural cycles. And that's going to be the basis for what we'll talk about in this class, right? So you need to understand the physical geography of planet Earth, right? If you're going to talk about climate change, you got to know about the atmosphere, right? If you're going to talk about why dams might be good or bad, it may pay to know something about how rivers work, right? Or if you're talking about overfishing, it might be important to know about the ocean. So we'll talk about all that kind of stuff this week, talk about some of the major systems. And a lot of this is going to kind of just set the framework or the groundwork for these later lessons that we're going to talk about later in the semester. And then on next week, we're going to be looking more at the human side of things. So we'll be looking at human development. And I have a whole another class, human geography, which we'll basically do what we'll do in a day or two, and spread it out through a whole semester. So if you're interested, but basically what people do on top of the physical environment here, and then we'll talk about issues of sustainability, which will underlie a lot of the major environmental catastrophes, which we'll talk about in the class, like how do we live sustainably within kind of the ecological limits of our environment. Okay. So I'm going to start off with a video about physical geography, and then we'll kind of work through the PowerPoint, talking about some of the big terms which you might need to know for this chapter. So let me pause this. All right, so we just checked out our first video of the semester, the crash course on physical geography. I'm going to put the link on Canvas, so if you missed the class while watching this video, you can watch it at home. We're going to talk about it, and then we're going to look a little bit at chapter 1, which talks about these same themes. So based on what you saw, what is physical geography? What do you think? What are we going to talk about today?
Study of just the land, you know, how to interact with stuff.
Yeah, the land. What else? There's more than that. There's more. Ecosystems, the things that live on the land, the plants and the animals. What else?
The history of events that might have happened.
Yeah, the
related
people,
to
the cultural history, the way that landscapes are shaped by people. We think this is like a modern thing, like, oh, we cut down the rainforest. People have been modifying landscapes for a very long time. We can also look beyond the land, right? To the air, to the water, to the oceans, right? All these different things. And you saw in the video, they used Iceland as an example. If you were a geographer, right? Geographer is like a big title. And that's like for an outsider, like, what do you do? Like, I'm a geographer. But if you're at like a geographer's club or you're at the geographer's convention, everybody's a geographer. Everyone has specialties. What are some of the different specialties you might pay attention to if you grew up to be a geographer? It might be some of, what was that?
Ecologist.
You might pay attention to the plants and the animals, right? The ecology, or the, you know, beyond individual species, the whole ecosystems that are involved there. What else might you focus on?
Geologist of local speed.
Yeah, you might focus on that. I got a lot of friends back when we lived in West Virginia who got geology degrees, right? Because they wanted to work at mine companies and look for oil and gas and coal and stuff, right? So you can focus on the different sedimentary layers of rock, or you can look at over here is an outcropping of this kind of rock or this formation, right? What else might you do? Got rocks, we got plants, we got animals.
A meteorologist?
Yeah, you might say the weather, right? They still do, I guess, have people on TV and be like, hey, there's going to be storms next week, or weather's getting warmer, weather's getting colder. We might also look at that over longer periods of time, right? They give you like the 10-day forecast, but we might be interested in climate over long periods of time. When I was in graduate school, they had one of the other departments had ice cores. And they were studying climate change over very long periods of time, hundreds or even thousands of years. They'd go to Greenland and take these big cores of ice, and they had them stored in the freezer, and you could see the different layers, you know, whether it was a lot of snow that year or not a lot of snow. And just like you could look at tree rings and see, you know, what kind of climate was that year, they were doing that with ice cores, and they did it with lake sediments as well in Mexico, where I was. They would drill down into the lakes, and they were able to see, again, over hundreds or thousands of years even, how much had got deposited in what years. So we might look at the climate, we might look at short-term weather, but we might also look at longer-term weather. We might also look at soils. I have a friend from when I was working agronomy who is a soil scientist, right? Looking at the different kinds of soil. We worked together because I was doing agronomy. And he was like, well, you know, like it's better to plant this kind of plant over here than that kind of plant. And we were doing it on whole regions. Like, well, this, you know, outcropping of you know, land is better for citrus, and we should plant citrus over there, versus this one is, you know, down by the rivers better for vegetables or things like that. So we can be interested in those kind of things. What else? We got climate, soil, human, the biosphere, the ocean. We might look at cycles in the ocean, especially kind of both the inorganic, like the currents and the waves and things like that, as well as the plants and animals, both microscopic like krill, all the way up to the macroscopic like blue whales, and how those all fit together. You might also be interested in kind of what's called biogeography, or the way that plants and animals are distributed across the landscape, right? Like what plants and animals live in certain regions and don't live in certain regions. This might also, again, tie into kind of economic aspects as well, right? Like what kind of plants can we grow in this region, or what kind of animals would do well in this region, and how can we make money on that? All of those topics, though, have other departments, right? You can go to a department of meteorology, or you can go to an ecology department, or a biological department. You can go to study human history. All these different things that we've talked about have their own departments. But how maybe is geography a little different if you study it from a geographic perspective instead of from the perspective of biology or history or something like that? What do you think? How might what we're going to be doing in this class be a little bit different? The humanist, yeah, it's more in the other one, the human geography. We are going to do a lot of, these are all human related disasters we're going to talk about. So we will be focused on the humans, and that's often really different from if you're in biology, there's a tendency, not as much anymore, but in the past, right? And there still is among some people, to focus more on like, well, let's just see what would happen, notwithstanding humans, right? What's going on in this biological system. But we're going to be looking at, the interaction of people with their environments. But what else really sets geography apart?
It's looking more at the bigger picture of the whole population.
Yeah, big picture. And picture is kind of a key word. Yeah.
It's what goes on in the present and future.
The present and future, maybe. You're all real close. But I think when we talk about geography, picture is a very interesting word, because when we look at things like this, right? Why is this geography?
Can't see it.
Oh, you can't see it. Oh, this double screen thing is driving me crazy. There it is. Geography. What does geography mean? What is geo?
Earth.
Or earth? Ography? Graphy? The graph, you study, but also to graph, right? Like the picture, right? And that's a lot of what we do in geography. We are picturing the earth, right? We are literally picturing it. And this is not like a real thing, right? Like, I mean, it kind of is a real thing, but it, especially until they invented spaceships in the 1960s, geography, we are taking like the real thing out there in the world, and you're putting it onto a map, right? Whether that's a paper map and you're Magellan out there sailing around the world putting things on the map, or you're doing GIS working for city planning over in Close or Portales, right? What a geographer does is take the facts of the real world and think about them spatially, right? This is why geography departments are often renamed now like departments of geography and spatial information systems and things like that, because a lot of what we do now is on computers, and we figure out how to take the information that's going on in the outside world and put it onto some kind of visual representation, right? This can be things that are relatively static, like the shape of the continents. They'll change, but probably not in our lifetimes, right? Unless something really terrible happens. It's probably going to be millions of years before the shape of this map goes out of date. But we can also do things that are much more fast changing or fast paced, right? Like we can map the wildfires in California. How often would that map need to be updated?
Constantly.
Yeah, constantly, every day, every hour, every minute, right? Like as the fire moves, it gets hotter in certain places, less hot in other ones. You'll have to change it. And that's an important part of what geographers do as well, is kind of, well, I guess that's a good question for you. Why might that be important? Why might something like mapping these fires be important? How does geography have real world relevance beyond like, isn't that cool that that's a map?
Public safety.
Public safety?
Yeah, those parts, just people know where.
Wildfire's coming to your neighborhood. You should peace out. Or if I'm in charge of fire department there, I can be like, send firefighters that way, right? Instead of that way, right? So geography, like oftentimes it's like, well, like why do we need geographers? I'm pretty sure we've discovered all the continents. It's really important to like think about how these formations, whether they're on really big scales like continents and rainforests, down to like really small scales to like fires in your neighborhood, or if there's a snowstorm coming next week, how all these things kind of fit together to be a bigger part of conveying information to the public. And I think that's like why we're going to talk about these important environmental issues from a geographic perspective, instead of this being like an environment class or a biology class or a geology class or something like that. We're going to talk about it from a geographical perspective, right? So we're going to look at a lot of spatial data. We're going to look at how these things change across space and across time. And we'll also think about the human dimension involved in them as well. So let's, seems like we were a good place to start on the PowerPoint. I need to switch back to duplicate because this is going to drive me crazy. Okay. So this is on your piece. Do I have it active out? We'll do that later. Okay. So is there a full screen button? There we go. This is the PowerPoint for chapter 1. You can find it on Canvas. Anybody clicked on it yet? Yeah, good. Means it works. It's a little different from previous semesters because this is originally for the 8-week class. So this one is slightly different just because the organizational scheme, but we're going to be using these throughout. I got to make a couple new ones because we have a few more chapters, but that'll come in week 3. Okay, this is the textbook. Hopefully you get it, or you got it, or you will get it. If not, I'll try to get one through the library. And at least try to get an ebook. I really don't like ebooks because I feel like they're just going to turn them off someday and we're not going to have access to them anymore. But in this case, it might be important to get one sooner than later. Okay, and we already talked about this a little bit, right? Planet Earth. And it's really interesting, these kind of images. What are we seeing here? And how is that different from the last image that we just saw of planet Earth? From the moon, right? And this is an actual picture. This isn't like the other one was like a graphic representation, but this is an actual picture. And it's not a coincidence that the modern environmental movement, which, we're going to be, thinking a lot about the issues that are kind of central to the movement, really emerged at the same time as people going up into space for the first time. Why do you think there's a connection? Yeah, you can see the Earth. You can see that we're all on the same planet. You can see just how hostile to human life the rest of the universe is, right? Like you're on the moon, or you're floating in an orbit around the Earth, and you take off your helmet and you're gone in 2 seconds. But the Earth is the only place that we have. There, people talk about terraforming Mars or Venus, but like that's gonna be like 100 times harder than just like fixing this planet that we already have that works, right? So a lot of what we're going to be doing, in this class in kind of broader, broad strokes is thinking about kind of the Earth as this dynamic system, but as an ecosystem or as a contained system, and how it's really different from a lot of the other places in the universe. So if this is the only place in the universe that we know that we can live on, that can sustain human life, and we know that there's really no plan B, and the moon doesn't seem to offer a place to go, or Mars or Venus, then why this? Why trash? Why pollution? Why toxic waste? Why smokestacks? What's the disconnect here? Yeah, we use nature's great, but like, why? Why, if we kind of know intellectually now, especially you've grown up in this era, that this is our only planet, we need to take care of it, and you've heard this since childhood. So why is there so much of this still going on? Yeah, commercialism, right? People making money, businesses. maybe lack of regulation, right? Maybe in some places they don't have laws that say you can't have a smokestack right next to an elementary school, or they don't say that you can't put your trash in the water, or that it's somebody else's problem. We had this when I lived in Belize for a while, in my office right down by the beach, and there was always beach cleanups, and everyone would come out and clean it up, and it was really nice for a day or two. But we were right, 20 miles from Guatemala, and people over there would throw their trash in the river and it would just wash down to us. And, oh, now we clean it up again, right? Like there's always, there can be political issues that cause these kind of frictions. There can be all kinds of class issues as well. Do you think that this is a rich area of town or a poor area of town? How do you know? How do you know? Yeah, right. And we talk about environmental justice, and then oftentimes whether it's the third world getting kind of the industrial trash, if you like recycle your phone, you're never like, I wonder where that went. I have friends in Belize who are like, oh, I remember growing up, we used to like get car batteries that were recycled from the US, and we would melt them down and make a big fire and melt them down and get the lead out and sell the lead to fishermen for fishing weights. And I was like, that seems just terribly toxic, right? But this is the kind of work that doesn't happen in the United States. Why? Because it's terrible and it's toxic, and we would rather just send it somewhere else. Or people in Africa picking through old phones and melting down the circuits to get the gold out, right? It can also happen within a country, like within the United States. I used to live in Appalachia in West Virginia, and their environmental risk and hazards there are a lot different than they are if you live in like New York City or you live in LA or something, right? There are going to be different risks. There's going to be, we have risk about like landslides and mountaintop removal versus if you live in LA, maybe it's risk of smog and a fire and things like that, right? One thing that I think is really interesting is that in the past, global environmental hazards used to be concentrated in really poor areas. But I think now it's increasingly creeping into rich people's areas. And we see this in LA. It's like movie stars' houses are, catching on fire, or they're forced to kind of deal with these things as well. And maybe that's what we need to affect global change, right? So have some rich people affected. We also can talk about kind of longer term changes, things that may not seem as obvious, right? This is agriculture, right? And we think of agriculture as basic to human life. But if you've taken my Origins of Human Diversity class, you know that we don't get to agriculture to the very end of class, right? There's a whole lot of human history before we get to agriculture. How might something like agriculture impact planet Earth? Yeah, right? You cut down the forest to plant new crops. What else?
Over time, the soil gets used.
Yeah,
and
gets
used again
depleted.
again, nutrients or.
You might get too much salt. You might have less nutrients. You might. Was that?
Takes a lot of water.
Takes a lot of water, right? And especially in our modern time, fertilizers and gas for tractors and things like that. But even in what we would think of as relatively small scale societies, right? This is changing both our physical bodies, because what we eat really impacts, how we live, whether you're a hunter-gatherer versus a farmer, but also the face of planet Earth. And we're going to talk about these kind of issues in a later chapter as well. Another chapter that we're going to talk about this semester is transportation, how we move around, right? For a lot of human history, moving was pretty slow, and not even that long ago. My grandma didn't have a car when she was growing up. They had a horse and buggy, right? Levi-Strauss, the famous anthropologist, was fleeing Nazi Germany and had to go to South America to do his research, and it took him 30 days on a steamship to cross the ocean, right? And that was like less than 100 years ago. But increasingly now, our world is very fast paced, whether it's planes flying us around the world or everyone needing to have a car. It's a busy world, but how do we account for all that pollution? When we fly places or when we drive places, how do we take into account what may seem like a small amount per person, but then once everyone's flying around the world and everyone's driving a car, how those things can build up over time. We also have this kind of industrial heritage we're going to take a look at this semester, factories and smokestacks and things like that. It's not quite as much around these parts. We're not as industrial, but we do have them over by the cheese factory and, the former peanut factory, God rest its soul. But especially in the upper Midwest, I know we used to live right outside of Chicago. the entire kind of south side of Chicago is dominated with a skyline that looks kind of like this, from all the way from like Gary, Indiana, all the way up to Milwaukee, right? You get these kind of big industrial factories producing things, whether it's tires or cars or chemicals or things like that. And then with these smokestacks kind of spewing out chemicals into the air. We're going to look at some of the efforts that have been done to make that a little bit safer, putting scrubbers and other kinds of filters on these smokestacks, but also some of the lingering kind of issues. And this can be relatively acute, like you can get sick pretty quick from, if these are spewing out toxic things into your local neighborhood, or they can be longer term as these things which seemingly don't really affect you at the present. You're like, look, I've lived in this neighborhood for 30 years, and nothing's ever happened. And then, you start to look around at the cancer rates, and they're much higher than, maybe the other direction where the wind doesn't blow those chemicals into the neighborhood, right? So we're going to look at some of those issues as well. But to understand all those different issues, whether it's transportation, whether it's, industrial industry, whether it's farming, whether it's waste, we're going to have to understand the physical geography first. And in a lot of institutions, if you were a geography major, you would take an entire course called physical geography, and it would be like the different things that we're going to talk about today, but spread out. Like you'd have a whole chapter or more on rocks, right? You'd have a whole chapter on the weather, and you'd have chapters on the continents and, tectonic plates and things like that. But we're going to try to just cram this into what's what you need to know in order to talk about these issues that we're going to talk about in the book from an educated perspective. Okay, so when we talk about it super basic, what are the four main elements? This is like Avatar, if you've ever seen it, right? Land, air, water, and life. This is the four major systems which we can think about. First three of these are not related to living systems. They are what we call abiotic. A meaning not, biotic meaning life, and the last one, biotic life, right? And they all work together. And some people have, since the 1960s, this what's known as the Gaia hypothesis, that these systems really interact to form one living organism that is planet Earth, right? Like we look at it, the water is like its blood, and the atmosphere is like breathing, and the people are like the cells, and right, and it all kind of goes together. And so when we talk about these different systems, we'll talk about them as separate, like, oh, this is infecting the water, or this week we're going to focus on the air. This we're going to talk about mining in the earth, but really it's all going to be affected, right? As you talk about, we'll talk about some of these cycles here in a second, and we all kind of know this, that as water evaporates from like a pond, it goes up into the sky, and then it rains down, and it can cause erosion on planet Earth, and that can cause different forms of plants and animals to live in certain areas. Okay, so what are those different spheres? The first of these are the fancy names. Lithosphere, this is the sphere of rocks that make up the foundation of Earth. This is something that you could study on a bunch of different planets, right? We can go to Mars, or we can go to Venus, we can go to Mercury or the moon and study the rocks there, right? This is pretty common throughout the solar system. So in many ways, the Earth is very common in this. We do have a lot of differences, and if you took a physical geography or geology class, we talk about the active core of the Earth and the mantle, and how we have plate tectonics and other planets do not. But in general, rocks are common throughout the solar system. But there are different kinds, and we'll talk about those in a second. The second of these is the atmosphere. This is the air we breathe. This is more rare in the solar system, right? We have some bodies in the solar system, like the moon, which have no atmosphere, right? They're just airless rocks. Other places have atmosphere, but they're not necessarily conducive to human life, like Venus. It's got an atmosphere, check mark, but you can't go there, right? You wouldn't last a second, and it's very toxic and high pressure and acidic, and it would melt your skin off. So we can study that when we study the Earth's atmosphere, this is going to be important for a number of chapters, like on acid rain and on climate change especially. We can study not only that there is an atmosphere, but what types of gases are in that atmosphere and how those percentages have changed over time. We've seen higher increases in CO2 or in nitrogen or in other chemicals, which might change the way that the atmosphere functions, either keeping more heat in or radiating more heat out into space. Within the atmosphere, we might also talk about meteorology, right? Like cloud formations, and this is probably the way that people, I think outside of like academia, probably interact with geography the most is like looking at that weather app on your phone, seeing, oh, there's a storm coming, right? We're all experts now at reading radar maps and trying to discern if we're going to make it to Albuquerque before it rains or before it snows, right? And so we can look at both the formations of those clouds and the 10-day forecast. We can look at the the 15-minute forecast, but we can also look at bigger climate change patterns, right? So we can look at things like the El Nino and La Nina systems in the Pacific. And we can try to, say, oh, well, this is going to be a big year for fires out west because there'll be less moisture in the air because of El Nino or La Nina, right? And we can also kind of think about these upper layers as well, because the atmosphere goes until it reaches space. So where is the boundary of the atmosphere, and how does that interact with the rest of the planet? We can also talk about the hydrosphere. This is with water. Again, if the lithosphere, if we were on another planet, we could probably find rocks to study. The atmosphere, we may have a harder time. And the hydrosphere is going to be really difficult, right? Because there is not many, if any, planets where we have found liquid oceans and water. We found other things in the solar system. We've even found ice. But this idea of the amount and the quantity of water that we have on planet Earth is really exceptional in our knowledge of the solar system and the universe. And this can be water on the ground, can be everything from a small pond to a river to a lake, to bigger bodies of water like lakes or seas and oceans. It can also talk about the way that water moves, right? And that can be flowing from a glacier up in the mountains and melting and rolling down the hill to a river to bigger and bigger bodies of water till it reaches the ocean. You can also talk about the evaporative cycle as it moves from the water in a pond up into the clouds and comes back down as rain or snow. And finally, we're going to talk about the biosphere, the living world, the plants, the animals, the insects, and the microscopic organisms, which help make our planet go. And without that, Earth really wouldn't look the same, right? We imagine the Earth, we say, oh yeah, it looks just like this, right? It's just the natural sources. But this wouldn't be the same without all the plants and animals, right? The plants change and the animals change the atmosphere, right? We change the compositions of the gases. We change the soil, right? There's bacteria that break down rocks into soil. There's other fungus and bacteria which take dead things and break them down into new soils. There's creatures like coral, which live out in the ocean, which can make coral reefs that eventually can become whole islands. Like a lot of the islands in the Pacific are built on literal piles of coral, right? And we can think about both the ways that plants and animals interact with each other, as well as next week, how they interact with people. Okay, so let's look at these more specifically. We talk about lithosphere. We can talk about different types of rocks. This is like Geology 101, if you've ever taken that class. Igneous, metamorphic, and sedimentary. What is the difference? Do you remember? Anyone had this like in, I think it was 9th grade for me. Long time.
Igneous is formed from
Magma, yeah, it's volcanoes, right? It comes out of the center of the earth. There's a molten core within the earth, and it leaks out in certain places. We call those volcanoes, and it forms rocks when it cools, right? It can form lava, and it comes out of the surface, and then it hardens, and it can form either very like pumicey lava. Like if you've ever seen pumice, it's like a rock, but it can float because there's so many holes in it. Or it can form things like obsidian. You all know obsidian glass is? Like if you're in archaeology classes, right? It's the stuff that you can make arrowheads out of. It's volcanic glass. It's super sharp. You can also have things like plutonic rocks or granite, which is when you get lava that flows up through the mantle into the crust, but doesn't like leave the surface. And this can form things like granite, which you might have on, well, probably you don't have those in your dorms, but fancy people might have those as countertops or build like statues out of it. Volcanoes are super interesting, and we're going to talk about them. We're not going to talk about them as much as little Eric would have liked to when I was a kid. But volcanoes are super interesting, and we will talk about them in the natural disasters and hazards chapter, which comes towards the end of the book. Do you all know what this volcano is? Yeah, the Mount St. Helens, right? One of the biggest natural disasters during that era, in which a major volcanic eruption exploded in Oregon and or Washington, and sent ash all over everywhere and blew the top off that mountain, right? And we can look at some other ones throughout the course of this class, places where this has happened. But volcanoes are not just a natural disaster, but they're an important part of this kind of lithic cycle in planet Earth, right? As the core of the Earth kind of moves towards the surface, replenishing the Earth. And just like how coal can make new land, volcanoes can make new land as well. Anybody know an example of a volcanic land? Hawaii, right? These are volcanoes underwater, and as they spew out lava, it forms these undersea seamounts, which eventually break through and form the islands that we know. The second type is metamorphic, right? These are rocks that are buried under layers of heat and pressure. They become distorted and form new kinds of rocks. This can either be inorganic. You can take limestone and turn it into marble, or it can be organic, right? And we all know where like coal comes from, right? Like if you've ever been to the Natural History Museum over in Albuquerque, right? You've seen the display. You got plants and animals in a swamp kind of build up over time, and the heat and the pressure compresses it. And where I used to live in West Virginia, there was huge seams of this stuff, and you could go in the coal mine tours, and you could see these layers. And what's really cool is that sometimes you can even see like fossils or imprints of like palm fronds or creatures which were once living in these areas, and they got compressed into coal. The third kind is sedimentary. And this is what you might see near a beach, and you might be like, why does that looks like the desert? That doesn't look like the beach. Why might sedimentary rock be over there in the desert? What does that tell us? Yeah, it used to be underwater, right? Sedimentary rock is formed when you have kind of layers of depositing of rock grains or sand. And usually this could be by wind deposition, but usually it's by lakes or soils kind of building up underwater. And then it can get removed, and we can see the layers as it gets kind of worn away. And it's really cool because it lets you, again, kind of see these geographic layers through time. I went on a 21-day Grand Canyon rafting trip one time, and you could see as you went down from the beginning, and you're like, oh, this is not like the biggest canyon. But every day you went down further and further and further. And it was really cool, in the guidebook, you could look and you could be like, and this layer right here represents a time 5 million years ago. That's pretty old. And like this one is from 50 million years. This one's 100 million years. And you could kind of chart, the history of the Earth there through looking at these layers in the rocks. For our archaeology students in here, you can also get organic. And this is a great example of organic rock. How do you get organic rock? That's weird. What is that?
Fossilization.
Yeah, it can turn into fossils, right? You got a dinosaur bone, turns into a rock fossil, or what is this thing? Can you see it?
Wood.
Yeah, it's petrified wood. One of the coolest rocks, I think, because it does keep its ring structure, and so you can still use it to, you can line it up with other trees that are not turned into rocks, and you can actually get climate data from a long time ago. That's pretty neat. Okay, so we can also talk about the atmosphere. Let me see how much time we have. We're doing okay. Okay. When we talk about atmosphere, we think of it as like air, but it's not just like air. It's a mixture of gases, and it needs to be a very specific mixture of gases to keep the planet running the way it is. If we have 78% nitrogen, 21% oxygen, and a bunch of other little trace stuff, including carbon dioxide, which I always assumed was much higher because, we're breathing out carbon dioxide. But this really needs to be in a very specific way, or us and everything else that's adapted to this atmosphere is going to have a really hard time. It has changed over time. My kids are little, so they're really into dinosaurs. And, we know that the oxygen level was higher back in the dinosaur era. That's why you see big dinosaurs, and we don't have giant creatures running around today. But this change takes place over very long periods of time, right? And if it changed suddenly, we wouldn't have time as creatures to adapt to it. But it is changing suddenly, so we are kind of forced to adapt, and we may be forced to figure something out, maybe successfully or unsuccessfully. when we talk about this though, it's not just the gases, and this is going to be, you know, if you were again looking from space, you would see these kind of readings, nitrogen and oxygen levels, but also you could see the amount of water vapor in the cloud. Some places around planet Earth have a lot of water vapor. This is not one of them, right? We live in a very dry environment, about 8 inches of rainfall as our average last year, and some years we don't even get that much. Where we just, I just went to Belize over Christmas break on a research trip, and the village I stayed in had 140 inches of rain every year. It's a little bit more than here. And how do you think that's going to affect life broadly in these two different environments? You have one environment that's an 8 inches of rain a year, and 1 inches that's 140 inches rain.
One's gonna look a lot more green.
Yeah, it's like overwhelmingly green versus here. Like it's like green. I don't really like the color green. I was like, I think that's just because you haven't like been around it very much, and you're very New Mexican, right? Well, so we got different amounts of like plant matter. What else might be? And also the different kinds of plants, right? What the kinds of plants that grow in a tropical rainforest and the ones that grow here on the Llano are very different. You know, like you can't grow cacao here, right? Like you can there. What else? The weathering, right? There are these big gullies and riverine formations there because it just rains so much, and it's very hilly, so it's always running away. So you have these kind of like sculpted hills and valleys, which we don't really have here. It's pretty flat. What else? How about like the air? What's that?
More humid.
Yeah, it's more humid, right? Now the people over with are like, oh, my hair, it's going crazy, right? Like I'm from New Mexico, my hair's never had this so much humidity before. Oh, my skin, it's so soft, right? It's not all cracked and bloody like it is back home. It can really make a difference, right? And then the way that you know, we as humans affect those cycles of atmospheric gases and of water vapor can really affect local environments, right? And we often tend to think of them as very stable, like, oh, this has been, you know, the climate here is always stable, but we can see it change in pretty quick time periods. One of the Facebook groups that I'm on as like a research thing is the Old Portales Photo Memories group. Has anyone seen that? You're all young, you're not on Facebook, you don't know. But I count it as research. How might we learn about past climates here in Portales by looking at old photos of Portales? How do you think it's changed? What kind of things do you think I've noticed in these old photos that I said, huh? Yeah, there's more roads and buildings, not as many as you would think, sadly. It's pretty similar.
That's farmland.
There's a little bit less farmland now, surprisingly. There's a lot more water. There's pictures of people like, looks like they're like stand-up paddleboarding in these acequia systems out here. You know, like there's water on the surface here. Did you know the term, where does the term Portales come from? What are we named after? Do you know? Porches, but like what does that refer to? People just like porches here. It is nice to have one. But it's from Portales Springs. There was a spring, if you go like out of town towards Arch, there is an old, like a kind of a spring that came out of a cave and had like an overhang. And they call it the porches, right? Because that's what it looked like. And if you go there now, you will not be able to find it. There is no water coming out of the spring. The spring is completely covered with sand dunes. It's all gone, right? There's another one of my other, I just did an article about climate change in eastern New Mexico. And we send the article in, and they're like, well, how do you know that it's changed? We found a picture in the archives of Blackwater Draw. Has anyone been out to Blackwater Draw site? Do you know where it is? It's like, if you leave here, turn left at Walmart, like you're going to the south gate of Cannon, you know, it's just past Oasis State Park on the left. For those of you who've been there, what's it look like now? If you go down into the site, it's hilly desert. And have you been down to the bottom? What's it look like there? It's just like a hole in the ground, right? We found a picture from the 1970s when they were doing gravel mining, and there's a large barge, like a boat that's big, almost as big as this side of the building, floating in a lake there, digging out gravel. We can be like, well, look, this is like actual climate change. There used to be a boat that you could drive around in this place, and now there's no water anywhere here, right? So we can kind of see how those things impact us on, you know, small variations. Another way I like to do this with pop culture, this is one more thing, is to, you know, kind of look at literature. There's actually, there's a romance novel written about Portales. cowboys in Portales. It's really cool. But one of the things they talk about is all the water everywhere in the book. And I was like, where? This is can't be Portales. And the smell of lilacs in the spring. Lilacs in the spring. But this has changed because of the amount of water and the way that people, had the shift from dry land farming to the dairies, and the way that we've shifted from using surface water to using water from underground. And this leads into the next one, the hydrosphere. We often think of oceans, lakes, rivers, these kind of surface level water. We don't have a ton of it around here, but like we got lakes. You can go to rivers, go over to the Pecos or Fort Sumner. You can see the lake over there. But we can also think about the underground water, and this is probably the biggest part for this region. What's our underground water here called? Right under here. If you can actually dig underground and find water here. And if you go 20 miles west of here, you probably won't. Why? This is a good geography question. Yeah. Anybody know? We are right at the very edge of what's called the Ogallala Aquifer. Here's a map. It's like a large underground lake, and you can see it's mostly Nebraska, Oklahoma, Texas, but we do have a little bit right here in New Mexico. And this is, it looks really big, but it's actually shrank considerably over time. Here's a map showing kind of areas of concern. And red being declines, blue being increases. What about this area that we have in eastern New Mexico over here? What's our area look like? Pretty orange and red. And you can actually see the geographic impact of this. If you drive out like west of town, like you go to Melrose or you go to Dora, and pretty quick right after that, like there's not a whole lot. And you can actually kind of see these farmsteads and see when they were abandoned as the aquifer kind of dries up. It's like a lake, and so kind of on the edges, it's very shallow, right? And they're the first to lose water. And that's kind of another Facebook research group I'm in is the Portales Water Group. It's people complaining and arguing about water in Portales. But a lot of it is about like how, we as a community are having to deal with this issue of declining waters, right? Like, and how when you talk to old timers, we did an ethnographic project a couple of years here, talking to people who had lived in the region for a while. What you'll always hear is just how the wells have to go deeper, right? Like, oh, our well used to be 50 feet. Now it's 75. Now it's 100. Now it's 200, because the water table keeps on declining, and how people have to deal with that. So we'll be talking about those kind of issues as well. Let's see, we got a little bit of time left. Let's finish this up. Where did I lose my PowerPoint? There it is. Okay. The last one we're going to talk about is the biosphere. These are all the living parts of planet Earth, right? This can be real macroscopic elephants and killer whales, or it can be microscopic. It can be like moss and kelp and things like that. This can be wild animals. This can be things that live out in nature, or it can be domesticated animals, such as like all the cows that live in those pens between here and Clovis. It can be plants, it can be animals, it can even be crustaceans and spiders and centipedes and things like that. They're all interconnected into what we call ecosystems, right? Eco being environmental or ecological, and systems being connected, right? And we can think about like how beavers build dams that fill up the ponds, with water, and then frogs and fish and insects live there, and there's plants growing in there now. Now ducks come live there, and now eagles come to eat the ducks, right? And then how it all kind of fits together. We can also think about how those change, right? And then how, if, for instance, a developer builds roads through there and disrupts that ecosystem, how it might change the plants and animals that live there. When we talk about biospheres in particular, this is in your textbook, you can check this one out. Certain biospheres have a lot more productivity than others, right? We can see like swamps and marshlands, as well as like tropical rainforests within one area, like an acre or a meter, are going to be a whole lot more productive than, say, like a desert or the Arctic, right? And we all kind of know that instinctually, but we can actually quantify this with how much carrying capacity a certain area has, or how much life it can support, or how much carbon it can produce. The last couple things I want to show you, because we're almost done, we can kind of come back to this at the end tomorrow, next time, is these cycles, right? This kind of water cycle and this gas, air, soil cycle. And again, this is kind of basic. You probably remember this from like Bio 101. But we can talk about these cycles and how things are interconnected, right? When we talk about the atmosphere, it's connected to the soil, right? And to the plants and the animals, because the plants are going to grow out of the soil using those nutrients, and the animals are going to eat those plants to get energy, and they're going to breathe, and it's going to change the atmosphere. And the plants are going to, use the sun for photosynthesis and convert that CO2 back into oxygen, right? It's all connected. And similarly, when we talk about the water, we have these systems as well, right? We got the ocean, but then it evaporates and goes into the clouds, and the clouds come in and rain down on places like Port Hollins, which don't have an ocean nearby, right? We got surface water, we got groundwater, all kind of connected. And these systems go together. And this is important because when we talk about these environmental disasters or these environmental hazards throughout the rest of the semester, they're all very complex, and they're all interconnected. And you can kind of see how changing, it's like a puzzle, a very complex puzzle, and changing one little piece can disrupt the rest of the system. So that's kind of where we're going to leave it today. Next time when we talk next week, we've set the stage for planet Earth, and now we're going to throw some people in the mix and see what happens when we add people to the environment. So come back next time for that.